Welcome back to WAPSI. So we can move to another section called electrostatics. Okay, by exam point of view, this section is very important, electrostatics. Okay, so we can move to the first question, and the first question is: a body has a charge of minus 3.2 microcoulomb. Okay, so what is meant by micro? 10 raised to minus 6. The number of excess electron it has is, okay, so we want to connect the total charge with number of charge and unit what's the value of unit charge. We want to connect all these data. That is given by the equation quantization of charge Q is equal to Ne. What is E? E is 1.6 into 10 raised to minus 19 coulomb. Okay, what is N? We have to find. What is Q? That is given inside the question. Okay, so N is equal to Q by E, that is Q is equal to, we can neglect the direction, we only want the magnitude 3.2 microcoulomb, that is 3.2 into 10 raised to minus 6 divided by 1.6 into 10 raised to minus 19. Okay, so that will equal to 3 point divided by 1.6 is 2, that is multiplied by 10 raised to minus 19 is going to upside, so it will be 10 raised to 19. 10 raised to 19 into 10 raised to 6 minus 6 is 19 minus 6, which is equal to 30. 10 raised to 30. 2 into 10 raised to 30, which is option C is the correct answer. Okay, so we can move to the second question. Okay, a point charge A of plus 10 microcoulomb. Okay, this is A plus 10 microcoulomb. Okay, and another point charge B. Okay, this is B of plus 20 microcoulomb are kept 1 meter apart in free space. Okay, so this is 1 meter. The electrostatic force on A due to B is F1. Okay, the electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. So then the direction of F1 and F2, see, both are positive charge, so they will repel each other, and this will be F1. Okay, that is towards the left, and the right will be F2, and that is pointing towards the right side because they are positive charge, both are positive charge, same charge will repel each other, so they are opposite. So F1 is equal to minus of F2 because the force equation 1 by 4 pi epsilon 0 can be treated as K, Q1 Q2. Here the for F1 Q1 is same, for F2 Q1 is same, for F1 Q2 is same, for F2 the Q2 is same for F1 and F2. Okay, that means the magnitude is not changing but the direction is getting opposite. Okay, that means F1 is equal to minus of F2. Okay, these both are positive charges. What happens if the both are negative charges? It's the same scenario, that will repel each other, and this F1 is equal to minus F2. What happens is if the one of the charge is positive and one of the charge is negative, they will attract each other. When they are attracting each other, here is the F1 and here is the F2. See, the both are in opposite direction. Okay, if they are repelling, they are in opposite. If they are attracting, they are in opposite direction. Okay, so in this case also F1 is equal to minus F2. So in every case, without looking to the magnitude of the charge, we can say that F1 is equal to minus F2. Okay, okay, then we can move to the third question. A uniform electric field is given as E is equal to 3 into 10 raised to 5 Newton per coulomb is acting along the positive y axis. So we need to draw the x, y, z coordinate. Okay, this is x axis, this is y axis, and this is z axis. Okay, and the electric flux through a rectangle of area. Okay, so first we want to mark the electric field, direction of electric field along y-axis. So this is electric field, which is given as 3 into 10 raised to 5 Newton per Coulomb. Okay, that means force per charge along the y-axis, and we have to calculate the flux through a rectangle of area 10 centimeter into 13 centimeter, whatever it is, whose plane is parallel to zx plane. Okay, plane is parallel to zx plane. So zx plane is this. Okay, so what is meant by this? The line, the normal to the area is this, and electric field is this. Okay, so the angle between the normal of the area and the direction of the electric field is 0. And what is the equation for flux? Flux is the number of electric field lines crossing a specific area, and the flux phi is equal to E dot A, that is equal to EA cos theta. And what is theta in here? 0. So phi is equal to EA, that means electric field into area, and the electric field is 3 into 10 raised to 5 is multiplied by what is area in here, 10 centimeter into 30 centimeter. We want to transform the 30 centimeter into meter. So 10 centimeter is 0.1 meter and 30 centimeter is 0.3 meter. So 0.1 into 0.3 is what? 1 into 3 is 3, and both have a 0.1 digit. So 0.03 meter square. Okay, so 3 is multiplied by 0.03, which is equal to 9 into 10 raised to 3. 9 into 10 raised to what's the electric unit of electric field is Newton per Coulomb, and the what unit of area is meter square. So Newton meter square plus Coulomb. 9 into 10 raised to 3 Newton meter square per Coulomb. Okay, so which equation? 9 into 10 raised to 3 voltmeter, both have the same, that unit are same. Voltmeter and Newton meter square per Coulomb is both are same. Okay, so we can move to the next question. Fourth question. The total electric flux through a closed spherical surface of radius r enclosing an electric dipole. Okay, closed spherical surface means we can imagine a ball. Okay, and enclosing an electric dipole. What is mean by dipole? Opposite charges are separated by a small distance. Okay, so first of all I am going to draw a spherical surface. Okay, this is a spherical surface, and then I am going to draw a dipole. Plus q and minus q are the opposite charges are separated by a small distance. Okay, see, we have to calculate the flux equation for flux, and in here they have given us dipole moment 2aq. Actually, what is mean by flux? Total number of flux passing through a surface. Okay, actually in positive charges the flux is going outward, and the negative charges the flux is coming towards the charge. So when we draw the graph, see, all charge lines which is going away from that means going out from the plus q charges will enter to the minus q charges in the opposite direction. Okay, that means if they leaving from here and entering from here. So what is the flux change? So what is the number of difference between the number of lines which is going out and which is coming to the spherical surface? That is 0. No net change in the lines. Okay, because the one charge is positive and the other charge is negative. That is the reason. We know that for a charge only a single charge placed inside a sphere plus q. That flux is defined as what? Epsilon q by epsilon 0. That is Gauss law. Okay, because the all charges emitting from the center will cross the surface area. Okay, so all lines are cutting the surface. There is no line coming from outside to the center part. Okay, that's why the electric flux is maximum in that case, and in case of dipole there is no flux. Okay, this is very, very important question. Okay, so option A is the correct answer. The zero flux is 0. And we can move to the fifth question. Under electrostatic condition of a charged conductor, which among the following statement is true? The electric field on the surface of a charged conductor is sigma by 2 epsilon 0. So they are saying that the electric field equation for the electric field on the surface of a conductor. Okay, what's the shape of the conductor? We don't know. Okay, it can be a metal plate, it can be a sphere. So by changing the shape, the equation for the electric field also get changed. So that statement must be a wrong statement. And the option B, the electric potential inside a charged conductor is always 0. The electric potential, no, that statement is incorrect, because the electric field is inside a conductor is always 0. The potential never become 0 inside a conductor. Okay, the potential is not non-zero inside, but the electric field is 0. Okay, any excess charges reside on the surface of the conductor. Yes, that is correct. Excess charges will only reside on the surface of the conductor. Charge is flowing on through the surface. That's why we want to increase the number of lines, number of threads inside a wire. In our household wirings, the number of minute wires are increased due to increase the surface area. Okay, that means we can increase the current going through the line. Okay, that's why we are using very thicker wires in order to connect high current. Okay, high current sources. We use thick wire. Okay, to increase the surface area. And option D is the net electric field is tangential to the surface of the conductor. That is wrong. The electric field is normal to the charge. Okay, that means the flux is going from the center towards outward. Okay, so for a conductor is in the cylindrical shape. Consider that this is a conductor which is in cylindrical shape. If there is a charge plus q on the surface, the electric field must be a perpendicular from the surface. Okay, not tangential. Tangential is wrong. It is perpendicular. So option C, the one and only correct option. Option C is the correct one. And moving to the sixth question, a cube of side 1 centimeter, contain 100 molecules. Okay, number of molecules is given, having an induced dipole moment of 0.2 into. So number of molecules n is equal to 100, and induced dipole moment P, dipole moment 0.2 into 10 raised to minus 6 coulomb meter, in an external electric field as 4 Newton per coulomb. Okay, the electric susceptibility of the material. So we want to connect the susceptibility with the dipole moment, electric field, and number of charge. Okay, so which equation? Xc is the susceptibility of the material. Xc is equal to P by E into N. Okay, so what is N? N is 100 molecules. Okay, so there is we don't want any kind of volume. That means the cube is 1 centimeter cube. So in by taking that, converting to 1 meter cube. 1 meter cube is the standard volume. So in 1 centimeter cube, it has 100 molecule. So what will be the number of molecules in 1 meter cube? See, 1 centimeter cube should be transformed to 1 meter cube. That means 1 centimeter should be transformed to 100 centimeter. So in one dimension it is multiplied by 100. So in 3 dimension it should be multiplied by 10 raised to 6. Okay. So n will be 100 into 10 raised to 6. That will be 100 into 10 raised to 6 is 10 raised to 8. So P is 0.2 into 10 raised to minus 6. Electric field is 4 is multiplied by 10 raised to 8, which is 10 raised to 2 into 0.2 is 20. 20 by 4 is 5. Electric susceptibility is 5. Yes, option B. Option B is the correct answer. In here, the one of the main step is to know the equation. That means the susceptibility is P by E into N and converting them into standard unit. In here the N is given in 1 centimeter cube, that is 100, but we want to transform that into 1 meter cube. Okay, that for that purpose we multiplied the N into 10 raised to 6. Okay. So the answer is 5 and the option is B is the correct one. So we can move to the 7th question. A capacitor of capacitance 5 microfarad is charged by a battery of EMF. So capacitance is 5 micro, that means 5 into 10 raised to minus 6 farad, and EMF. So the potential is 10 volt. At an instant of time, the potential difference across the capacitor is 4 volt and the time rate of change of potential. At an instant of time, the potential difference across the capacitor is 4 volt. Okay, so at that instant Vt it is 4 volt. And the time rate of change of potential difference across the capacitor is 0.6 volt per second. Okay, the time change, that means the rate of change of voltage with respect to time, that is 0.6 volt per second. That means we want to differentiate the volt equation. Which equation? Then the time rate at which, look, the time rate at which the energy stored. So we want to know the energy equation for energy inside a capacitor. So energy U is equal to half CV square. Here the C is constant and they have already given that the voltage is changing with respect to time. So we want to differentiate the energy. So du by dt is equal to half is a constant, C is a constant, the differentiation of V square 2V. Okay, and the 2 and 2 can be cancelled, so that will be equal to CV into dV by dt. With respect to time, the V is also changing, so dV by dt. So du by dt is equal to CV into dV by dt. So at that time, what is the voltage? For voltage, what is the capacitance? 5 microfarad, which is 5 into 10 raised to minus 6 is multiplied by the voltage. Voltage is what? 4 volt. At that particular time it is 4 volt. Okay, it's multiplied by dV by dt, 0.6. So the answer is 4 into 5 is 20. 20 is multiplied by 0.6 into 10 raised to minus 6. Okay, so 0.6 we can transform these zeros to here, that is 6. 2 into 6 is 12. So the answer is du by dt is equal to 12 into 10 raised to minus 6. The rate of change of energy is 12 microwatt. What is the unit of energy? So option A is the correct answer. Okay, so in here we must know the fundamental equation for differentiation. Okay, so we can move to the 8th question. Electric field. E is the electric field inside a conductor. Whose material has a conductivity sigma and a resistivity rho. Okay, the current density inside the conductor is J. Okay, the current density is inside the conductor is J. The correct form of Ohm's law is, see, what is Ohm's law? What does the Ohm's law? From the 10th standard actually you are studying the Ohm's law. Ohm's law states that the potential inside a conductor is proportional to the current. V is proportional to I and the proportionality constant is R. So, V is proportional to I, that means the potential is proportional to current. So, V is equal to IR. This is Ohm's law. Okay, so we want to incorporate this sigma, rho, J and electric field with this equation. How? And what is R? R is the resistance, and we know that V is equal to I into R. R is resistance. Resistance is equal to rho into L by A. What is rho? The resistivity of the material, the property of the material. Rho into L, length of the material. Okay, so R is equal to rho L by A. A is the cross sectional area. Okay, substitute this formula in here. V equal to I into rho L by A. Okay, and so V by L, we can take the L to the left side. The voltage per unit length is equal to current into rho by A. Okay, and what is current per unit area? And we already said that, I already said that A is the area of cross sectional. Okay, this is the conductor and this area is A. The current per unit area, what mean by that? That is actually that is given inside the question, current density J. Okay, so we can substitute I by A as J. V by L, voltage per length, is equal to J into rho. And what is voltage per length? If we have a potential given between a length, okay, that potential, then electric field is equal to, E is equal to voltage by length. Okay, so E is equal to J into rho. Which option is correct? E is equal to rho into J. Option C is the correct. We can substitute the resistivity by conductivity, that is also correct. So, E is equal to J by sigma. J by sigma is also correct, but that kind of option is not in our options. In our options, there is only one correct option. E is equal to rho into J. So, option C is the correct one. So, we can move to the 9th question. A uniform magnetic field of strength B, B is 2 millitesla. Okay, that means 2 into 10 raised to minus 3 Tesla, exists vertically downward. Okay, these magnetic field lines passes through a closed surface as shown in the figure. Okay, the closed surface consists of a hemisphere S1, a right circular S2 and a circular surface cone, of S3. The magnetic flux through S1 and S2 are respectively. So, we want to find the magnetic flux through S1 and S3, not S2. S2 is, they are not asking S2. Okay, how we can find? What is the basic concept related to the flux? Actually, flux is the number of field lines crossing that area. Okay, with respect to, we don't want to consider how the area is. Let the area be like this, and the number of field crossing the line is 3, and if the area is like a plane, okay, the same 3 lines are passing through this area. So, with respect to the area, we don't want to calculate the flux. We can avoid the area, we can avoid the shape. So, in here the 2 field lines is entering, and in here the 2 field lines is entering, and in here 2 field line is outgoing. So, we can take the area which is very convenient for us. That's why they are not asked about the second area. Actually, the second area is very good for us to calculate. the calculation get easier. So we want to use the second area, but they are not asking about the second area, but they are asking about the first and the third area. Okay, so for our purpose, and this radius is in centimeter. Okay, for our convenience we can use the second area. Okay, for what is the equation for a flux? Magnetic field into area. Okay, what is magnetic field? 2 millitesla. So flux phi is equal to 2 into 10 raised to minus 3 into area. Area is perpendicular to the direction. So into area. R is radius is pi by root pi. So equation for area is pi r square. Pi into r is 10 by root pi. So 10 square. Sorry, that is centimeter. We want to change the unit from centimeter to meter. So multiplying by 10 raised to minus 2 and taking the square, just multiplied by 10 raised to minus 4. 100 by pi, and the pi and get cancelled, is multiplied by 10 raised to minus 4. Okay, magnetic field is multiplied by the area. Okay, then 200 into 10 raised to minus 7, which is equal to 2 into 10 raised to minus 5, or 20 into 10 raised to minus 6. Minus 6 means micro, so 20 micro Weber. Okay, so which option is correct? For the first one, it is entering, magnetic field is entering to the surface, that will be positive, and in the second, the magnetic field is leaving from the surface, that must be negative. So first one, first flux is always positive, so option B can be correct and option D can be correct. Okay, and the second must be negative. So by considering that also, the second one can be the negative, and the D option, that is also correct. But the value, our value is 20 microweber. Okay, so the second one and the fourth one have the positive values as the first one and the negative value for the second flux. So the option B with the magnitude 20 microweber is the correct answer. Okay, so in here the main point is, whatever it is the shape, we can use the area in which our calculation become more easier. We can use that kind of areas. Okay, if they are cone, if the area is cone, don't mind that. If the area is a hemispherical, don't mind that. You mind the area which is plane, which is perpendicular to the magnetic field. Okay, take that kind of area. Okay, so we can move to the 10th question. The torque acting on a magnetic dipole placed in uniform magnetic field is 0. So the torque is 0. Okay, when the angle between the dipole axis and the magnetic field is what? See, what's the equation for the torque acting of a magnetic dipole? Magnetic, that is, torque is equal to B cross M cross B, M cross B, magnetic field B, and magnetic dipole M cross B. That means the angle between them to be calculated MB sin theta, which is equal to 0. So sin theta is equal to 0. So theta is equal to 0. So option C is the correct answer. Theta equal to 0. Okay. Bye. You can see on the next class.